Okay, hello. Happy Wednesday. Hello. Hi Natalie. We meet again. So let's continue with our revision last week. So we stopped around here, I think. Okay, we stopped around here. So let me just quickly repeat this lah. A very simple part which is here, also very important. Hang on, let me erase this real quick because I taught this yesterday. All right, so I think we stopped around here, which is the sex-linked disease part. Okay, have I mentioned this? I have, right? I have, right? We have two types of sex-linked disease, which is hemophilia and color blindness. That means they are carried by the X chromosome. Remember, we call them sex-linked because they're carried by the X chromosome, not the Y chromosome. The Y chromosome doesn't carry anything. So in this case, if a male, if he is X big HY, he is normal, okay, because he has the dominant gene. But if he is X small HY, then he has the disease. All right, and that's the only two possibility. But for female, since you guys have XX, okay, double X, so you can be big H, or small H, or big H, small H. So in this case, you can either be normal, okay, both genes dominant. You can either be having the disease, okay, both genes recessive, or there's a very special case, we call it a carrier. Okay, a carrier, big H, small h, that means you are normal, but you might carry the disease to your children. All right, so in this case here, we know this lah, we have done this lah. So if a normal father, if he marries a carrier mother, if they're having a daughter, then they wouldn't be worried. Oh, here's the thing, carrier is still considered normal. If in exam they ask you normal, we actually include the carrier, because for carrier people, they themselves, they are normal. It's just that their next generation might not be. Okay, so they are still considered normal. So if this couple, if they're having a daughter, then they need not worry because they are both normal. It's just that one is carrier. But if they're having a son, okay, if they're having a son, half the chance he will be normal, half the chance he will have a disease. Okay, in this case, we know that he has hemophilia. So 50% that he will have the disease. Okay, all color blindness. Okay, this one you already know. Right, so pay attention here. Pay attention here. This sex-linked disease, which is this hemophilia and color blindness. If color blindness, usually they will ask you to use C or they use B. Okay, X big B, X small b, or big C, small c. Up to the question. All right, so you get the point lah. You get the point. So we have, I think we have finished all the mutations already. All right, so the next part, which is our genetic engineering, right? Kindly do not focus here. Okay, kindly do not focus because it's very unlikely to come out in exam. Very unlikely, doesn't mean they won't. Okay, it's just that very unlikely they will come out. Right, so what is genetic engineering actually? That is the, how do I put it? The modification of DNA. All right, since this field is actually quite new. Okay, it's quite new. It's only been around for not more than 100 years. But these few decades, we actually found out how to modify DNA to, modify plants or animals to characteristics we want. All right, so like durian lah, as you know, durian has many types, right? You have D24, you have Musang King. You can either do selective breeding, okay, or you can just do genetic engineering. This is really cool. Okay, this is really cool, but it's not coming out, okay, because it's a very hard to understand field because it's very high level of understanding. Right, so you just need to roughly know what do we use it for. Okay, we use it to make insulin. Okay, we actually use genetic engineering to make insulin. Okay, what do I mean? Last time, if you want insulin, okay, if you want insulin, you have to get it from pigs or cows. Okay, you have to get it from the body. And as you know, if you get products from animals, it's either your body will reject it or you will piss off some vegetarians because they don't believe in, animal products. So this is how we do it. We actually take human body cells, okay, and we modify it to let bacteria make insulin for us instead. And this thing look exactly the same as our human insulin. So you have almost zero chance of rejecting it, which makes things, much better. All right. And of course, we use this to modify crops as well. Okay, modify crops to make our fruits bigger, okay, more nutritious, okay, more resistance to pests and disease so that they survive longer and higher yield. They can make more fruits, they can make more products, which is cool, you see. So indirectly, we use this to solve hunger. We use this to solve food problem. All right, and of course, there are advantages and disadvantages. All right, so what are the good points here? You can treat diseases, okay? You can treat hereditary disease. Let's say your child, okay, if you're pregnant and you found out that your child has Down syndrome, maybe you can use genetic engineering to solve this. Okay, we don't have this technology yet, but who knows, next time we will. All right. And here's the problem, you see. Here's the problem. If I can use genetic engineering to modify my future child, okay, to modify so that they don't get sick, why stop there? All right, you get what I mean? Why stop there? Why? Let's say my child has Down syndrome. I will modify my child not to have Down syndrome. And while I'm at it, why not I modify his eyes, okay, or his nose, or his intelligence, his athletic abilities, so that I can make the perfect baby. All right, so you can see this is a very gray area. Where do you stop? Where do you draw the line? Okay, for you it might be very unethical. It might be going over the line. But for some people, yeah, they you know they can accept this. All right, so everyone has different moral standards, lah. So it's a very hard thing to discuss. All right, and of course we can make quality plants, okay, quality livestock, more resistance towards disease, okay, require shorter time to harvest, okay, produce insulin enzyme. So you see, there's a lot of advantage in this genetic engineering, but so far our understanding towards genetic engineering is still very limited because it's a very new field. Okay, it's a very new field. So who knows that genetic engineering next time, they might cure cancer, right? So nobody knows. Okay, it's still a very new field. But what about some disadvantages? So it might cause allergy or side effect. Okay, so it might cause extinction. It might cause mutation, and of course it's unethical, and it might cause organisms, which is bad organisms, to have high resistance towards pesticide. So there are two sides to this. I'm not gonna go too much into this lah. It's not coming out in exam anyway. It's just cool to learn. Right? So anyway, moving on, let's go to the next part, which is the last part of this chapter, which is our variation. Right, this thing is for sure coming out. Okay, I'll put another star here. So as you know, I mentioned this not last time, this crossing diagram is almost for sure coming out, and so is this variation part. Okay, so this is very easy. So what is this? So we have two types of variation. I don't know whether you still remember this. We have two types of variation. Okay, what is variation? You and me, we look different, right? Everyone has variation. All these are just examples of variation. Okay, like for example, free earlobe, attached earlobe. You can roll tongue, you cannot roll tongue. You have dimples, you have no dimples. Curly hair, straight hair, black hair, brown hair, long eyelashes, short eyelashes, brown eyes, blue eyes, tall, dwarf. All these, they are variations. So we can generally put them into two categories. All right, you have two types of variation. You have continuous variation and you have discontinuous variation. Okay, so what is this? What is this? Okay, continuous, as you see, okay, let's just take this graph. Let's look at this graph. Can you see they are continuous? Okay, as the diagram shows you, they are continuous. And then as this says discontinuous, they just kind of look discontinuous. They are like pata pata one. Okay, they are not related one. Okay, so what? Do you still remember this? Do you have any idea of this? This one will be usually asked in the first question of a paper 2, which looks like this. Oh no, you don't. Okay, so this is the easiest part to solve. Okay, let's just give an example. Continuous variation. Let's just say height. Okay, you see, height, if you look at the people in your school, look at their height, let's say this is the graph, you have 145 all the way to 184. Let's just say example, right? What does it mean? That means 145 to 149. Do you have people this height? Yes, you do, right? I mean, they are really short lah. Okay, so they're around here. And then you have people 150 to 154. Again, you have people, but this time it's more. And then again, you have people 155 to 159. Okay, so what am I trying to say here is every height has people. Okay, you have people 141, 142, 143, 144, and all the way to 180 something. Right? So every height has people. So you see, can you see this is a continuous value? Okay, if you look at the definition, it says there shows difference that are not distinct. You cannot cut it into, clear classes. All right, in this case, like height, right? You cannot say, oh, this is tall, this is short. No, how tall is tall? How short is short? You can have very short, you can have not too short, you can have short. You see, you have many, many, many classes. So in this case, right, it is impossible for us to split it into classes. It is not distinct. Okay, so you cannot cut them into classes. They have intermediate values. So what is intermediate value? That means, like I said, in the middle, you have people 141, 142, 143, 144. Every intermediate, every middle value, you have people. So this is the meaning of continuous variation, and they are quantitative. Every class is about quantity. How many people is in this class, right? So this is your continuous variation. And interesting fact, since we are talking about height, right? It is affected by genetic and environmental factor. Okay, what do I mean? That means to grow tall, okay, Natalie, how tall are you? I hope you are 150 something. Okay, usually girls are 150 to 160 Malaysian girls. Okay, so wow, congratulations. Okay, you are at the male average height. I shit you not. Malaysian average male height is 165. Okay, so I'm sorry to say this if you want to find boyfriend next time, a bit hard The taller you are, the taller you, the more difficult to find boyfriend. Okay, and Malaysian guys they can't really accept that their 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 girlfriend being taller than them. I don't know This is just it's just this masculinity thing Okay. So anyway, you have friends like that. Yeah, tell me about it again. I have friends like that too. Right. Anyway, so your height, right? These are continuous variation, right? They are affected by genetic and environment. That means to grow tall, okay, to grow tall, first you must have the gene. Your parents must be tall, and I bet your parents are tall, right? And you must have environmental factor. That means you need to eat right, you need to sleep well, you need to exercise. Okay, do sports, Natalie? If you don't, then that means you have really good genes, right? Barely, yeah. There you go. There you go. How tall is your dad? And how tall is your mom? You should be around their, the height in between them lah. Okay, in between them lah. So I bet your mom is considerably tall. Oh, okay. Wait, that's a big range, like 170 to 177. How about your mom? How about your mom? So wow, you have very good genes, Natalie, I would say. Okay, you have very good genes. Ah, I see. Oh, that means your mom and your dad is quite close. Their height. Oh, then I can see why. I can kind of see why. Oh, okay. Okay, so genetic and environment lah. Okay, genetic and environment. Hey, who knew Okay, who knows if you did exercise, right, you can even grow taller. Yeah, but too late lah, okay, because you're 17 already. You're almost at the end already. All right, but hey, that's not bad. 160 something is not bad at all. Right, that's yeah, you girls will stop growing around 18. So you're almost there lah. You're almost your puberty is almost done. But okay lah, 160 something, you cannot ask for more lah. You're like the golden ratio already. Okay, anyway, so this is your continuous variation. Okay, as you can see, the graph looks like this. All right. So anyway, what about discontinuous? Okay, this is the complete opposite. As you can see, the difference, they are distinct. That means very clear cut. Let's take, for example, your blood group. Right, you look at your blood group, very easy. There's only four. Okay, there's only A, there's only B, AB, and O. There is no intermediate value. Okay, no intermediate value. Like just now, height, right? You can be anywhere in between 140 to 180, but not for blood group. You are either one of the four. You cannot say, oh, I'm half O, half A. Sorry, it doesn't exist. Okay, it's either you're one or you're not. All right, it's like your computer lah. It's either your computer is switched on or it is switched off. There is no such thing as, oh, I switch on my computer half. What the hell is switch on half? So this is a very clear-cut value. So we call it discontinuous factor, discontinuous variation. So the graph just looks like a bar chart. Okay, sometimes there's 3, sometimes there's 4, sometimes there's 2. Like the ability to roll tongue. It's either you are a yes, okay, or a no. So one of the two. All right, so as you can see, they are qualitative. It's either they are one of the class. It's about the quality. Okay, you are one of the four quality, or 3, or 2. All right, it's not about numbers. This is all about numbers, all about quantity. So this is about quality, right? And they can only be affected by genetic factor, no environment. Because you see, your blood group, does your environment affect your blood group? No, you don't say, oh, I sleep a certain way, I eat a certain way, I live a certain way, I can manage to change my blood group. No. All right. And the ability to roll tongue, same thing. Whatever you do, you will have the ability to roll tongue or not. Okay, you will stay there. So what other examples we have? Right, for continuous, right, we have body weight. Because body weight, I'm sure in your school, it goes from 30 something, like being really skinny, 30 something, that's like refugee height, refugee weight already, all the way to, I don't know, 100 something. Malaysia is very famous for obesity lah. So if you have someone at school 100 something, I'm not surprised. Okay, I'm not surprised. Okay, but majority, especially if you're a girl, I'm sure your weight is roughly around 50, right? Should be lah, should be. I mean, I know. I shouldn't ask about the weight of a girl. So here that goes. Okay, you're around 50 something, right? From girls are either from 40 to 50 or 50 to 60 lah. That's the healthy weight, I would say. 40 to 60 around there lah. Right? So anyway, so this is your continuous and discontinuous variation. This part is for sure coming out. Okay, I can guarantee you like 90%. So you see, so easy, right? This is a very easy part to score. Okay, as we shall look at the questions later. Right, so this one, please read it yourself. I'm not going to go into this because it's not important. Okay, anyway, so that's it about this chapter. Okay, so as many people said, this chapter is very difficult. I wouldn't say it's very difficult. I would say it's more difficult than other chapters. That's all. All right. So are they really that difficult? I don't think so. And more content to absorb. Yeah, I agree. Okay, so if you selectively want to memorize, selectively, you say, wow, sir, my brain got no space to put leh. Then you don't memorize mitosis or meiosis. Or for mitosis, meiosis, right, you can just sum it up with this table. That's all. That's all. Mitosis is to photostat, meiosis is to create different. That's all you need to know. How do they do crossing over or do they have variation? Is everything summarized here? The most important would be still your crossing diagram. Okay. If I were to choose things to memorize this chapter, I would say it's the crossing diagram. Okay, this is not really to memorize. This is, understanding and drawing it yourself. All right, the crossing one, which is related to your mutation, okay, your carrier, non-carrier, and of course your variation. So if you say it's a lot to memorize, I wouldn't say so. Okay, because it really isn't. I mean, compared to other chapters, maybe it's more lah, but still not a lot. Right? So the rest, I'll leave it up to you to digest lah. Okay, I'll leave it to you to digest. It really isn't that difficult. Right. Anyway, so let's go to our exercise, shall we? Have we done this? Have we done question 10? Where were we? I also forgot already. Were we at question 12 or 11 or? Damn it, I forgot. Okay, where were we? Where were we? Have we done the? I think we haven't done the top questions too, right? Okay, I'll finish this later. I'll try to do this later. Okay, let's go to 11. Okay, 11. 11. So that means we haven't done 11, right? We haven't done 11, right? Okay, hang on. Let me just erase this real quick. All right. So, sorry, I actually did this yesterday. So let's go to question 11. Okay, so the diagram below shows the chromosome structure of P and Q. Okay, we did this. We actually learned this last week. All right, so the first guy, the first individual, okay, there's a problem here. And individual Q, there's another problem here. Do you remember the name? Do you remember the name? What is P having? And what is Q having? Do you remember? P is a guy that kind of looks like a female. It kind of looks like a girl. And for Q, she is a girl, but she doesn't look like a girl. Okay, can't remember her name. All right, so for P, right, we call it Klinefelter syndrome. Okay, Klinefelter syndrome. You briefly know that. That's good. Right, you might say, hey, sir, why got this kind of weird name one? Because you see, all these syndrome, they are found by a certain doctor and they name it after that doctor. Okay, like Down syndrome, right? It is named after a doctor called Down. Okay, but the real name of Down syndrome is called trisomy 21. That means at the 21st pair, do you remember? At the 21st pair here, we have 3. Right? So the scientific name is called trisomy 21 because 3 and 21. So, but they think, you know what, trisomy 21 is very hard to call, it's very hard to pronounce, so they just call it Down syndrome. All right, they just name it after a doctor. So all these names, right, they are a doctor's name, Klinefelter syndrome. And then for X, this one is called Turner syndrome. I think I told you how to memorize, right? When you see XXY, you see long chromosome, so Klinefelter. You see, XXY, Klinefelter. That's how I remember. And then the short one, Turner. Because short, there's only one X, so the name also shorter, lor. So Turner. Okay, so there's only 3, There's only Down syndrome, there's only Klinefelter, there's only Turner. So there's no reason for you not to remember, There's only 3 names here. Okay, for crying out loud. So anyway, so moving on. So state the gender of individual Q. So individual Q, this person is still a female. All right, because this person has no Y here. So this is still a female. All right, it's just that she doesn't go through puberty. She has no puberty. She has no extra girly characteristics. She just looks like a girl, but she's not extra girl. Like she doesn't go through puberty. She doesn't have, female characteristics like having breast, having a period, and so on. Okay, so C, explain the difference between the number of chromosomes of individual P and individual Q. So difference, as we can see here, P has one extra. So P has 47 chromosomes. Okay, so what about Q? Q has one less, right? Q has one less, right? So Q is 45. All right. So in this case, you have to draw in the exam, you have to write the full sentence. Okay, P has 47 chromosome, Q has 45 chromosome. Whatever, okay. I'm not going to write the full sentence here. So D, state one characteristic of the disease experienced by individual P. So this is a male, right? So what is he like? So he has he has breast development. In breast development, he has white hips. Right, he just kind of look like a girl, and he is infertile. Okay, that means he cannot make babies. His sperm doesn't work. Right, for Q is the same thing. Q is the same thing. Okay, she's a girl, but she doesn't go through puberty. Okay, so we can say does not experience puberty. Oh, you can even say mentally retarded. Okay, mentally retarded. She is not like other girls lah. You have so many points to write here, right? You have so many points to write here. So there's a list for you to choose. Okay, then infertile, short, mentally retarded, no ovary, small breast, does not experience menstrual cycle. There's a list for you to choose, and same goes to your Klinefelter. Yeah, you just need one. Yes, you just need one. Don't need to go crazy here. All right. So number 12. This is your color blindness. This is a sex-linked disease. Right, so see if you can answer this. Okay, I'll write the answer, see if you can get it. So you see, normal father, right? So since they say they want big B for dominant, small b for recessive, right? So the dad, since he's normal, he should be X, big B, Y, right? Right? And of course, the mom being a carrier herself, what is a carrier? That means she is big B, small b. Okay, and then when they do meiosis is to split everything into half. So now you have X, big B, you have Y. That means for the dad, right, 50% of sperm is like this, 50% of sperm is like this. And then for mother, X, big B, X, small b. So the mom's ovum is either half big B or half small b. See which one you get, lor. See which one you get, lor. So when you do the crossing, you have big B, big B. This is exactly like our question, our notes just now. It's just that we use H just now. Just now was hemophilia. Now it's colorblind. So the first daughter, okay, this is a normal daughter. All right. And then the second one, X big B, X small b. This is a carrier daughter. I'm just going to write D here, carrier daughter. So like I said, if they are having a daughter, if let's say this couple, the mother got pregnant, and they go for a scan, they say, oh, congratulations, you're having a daughter, then they wouldn't need to worry because 100% they'll be normal. 100% normal. Yeah, maybe there's a carrier, but at least she's normal. But now, when it comes to the son, so X big BY or X small by. Right, so now the son either can be normal, okay, normal son, or he is a colorblind son. Right? So if they're having a son, if this mom got pregnant, they went for scanning. Oh, congratulations, you're having a son, you're having a baby boy. So now they need to worry whether 50% they will be normal, or they will have the color blindness. All right. So here's the thing. Here's the thing. You might be a carrier yourself and you do not know it. So how do you ensure? How do you, here's the thing. I don't know about you, Natalie. So if let's say you are a carrier for a certain disease, would you still give birth? Would you still have a child? Because if you don't mind, right, maybe your husband will, maybe your in-laws will. You see, so yeah, it's very controversial stuff, lah. So this is why, right? This is why, right? Before any, actually, it's quite recommended, for every couples, right? Every couples, before they give birth, or anything, okay, they should go for something what we call couple screening. Okay, couple screening. Yeah, it could be a rare disease. Nobody knows. Okay, so if you're very paranoid, you can go for a couple screening. You can scan, your husband go for a screening, you go for a screening to see whether you have some kind of very rare disease. You're a carrier of a very rare disease, because better be safe than be sorry, right? So nobody knows. Okay, I mean the chances are not high, but once you get it out, then wow, it's a very serious problem. So yeah, there you go. If you want, you can go and do a check. You can go and do a scan, see if you're normal or not. All right. So yeah, because you see, even I don't know about you lah, because some people they believe in not having children, but some people they die they want a child, they want children. So if your future partner, okay, if you guys differ in terms of these things, it could lead to a huge fight. Okay, because this is something that you should iron out before you get married. Okay, next time you understand, okay, when it comes to your in-laws, when it comes to money, okay, all these sensitive stuff, you should iron out with your significant other before you make the next decision, right? I mean, I know you guys are in love and whatnot, but I tend to realize this thing, when people are deeply in love, they just kind of throw their logical sense away. And when they get married, okay, when the honeymoon phase is no more, okay, when they start to face the reality of life, then that's when the fight will start to come, right? Word of advice here. Wow, I'm giving life advices really. That's not me getting old. Right, anyway, so what's the probability of having a normal daughter? Okay, it's 50%. Why 50? Because we consider carrier as normal. So that's 50% you have a normal daughter. Then a colorblind son, okay, there's only one colorblind son here. So the chance is 25%. I don't know about you, but 25% is pretty high. Okay, it's like 1 in every 4. 1 in every 4. If you want to bite the bullet and gamble, best of luck to you lah. Okay, but I don't know lah. I don't know lah. I think if you have any disease, or if you're not well to do, even you don't have a lot of inheritance, if you don't have a lot of money, I still think that giving birth to a child this way is very selfish. Okay, even you have no genetic disease, but you are not well to do, you are poor, and you decide to have a child so that he or she will suffer with you, that's just a very selfish thinking. Okay, because if you couldn't provide the best to your child or your children, and you die want to bring him or her to this world, and then when your family is poor or whatnot, you guys run into financial situation, and then you just look for something to blame. You blame your child, you blame your children. Because of you I have to give birth to you, because of you make me poor. That is just toxic parenting. Okay, please don't do that. I mean, our previous generations, they do that a lot. I hope your parents do not do that. Okay, because my mom do this quite a lot. Okay, so it's not a very healthy way to raise your child this way, because they will hate themselves. They will think that, why do I exist? Okay, I come to this world to bring trouble. So you see, if you're not prepared for it, so please don't. Okay, you want to make a serial killer? You know those serial killers, those are serial rapists, those they are brought up this way. Okay, they are brought up this way. They were abused when they are a child, so they grow up being a psycho. Right. Anyway, so see, color blindness is known as a sex-linked hereditary disease. State the reason. As I said, what does it mean by sex-linked? That means they are carried by the X chromosome. Okay, so why only in your case why only we call hemophilia and color blindness sex-linked? Because only these two, they are linked to your X chromosome. The rest, they are not. Okay, now you agree too, huh? Right, anyway, so because they are found, okay, or you can say color blindness is found in the X chromosome. Okay, only the X chromosome. So give another example. So since we have color blindness up there, another would be hemophilia. Okay, another would be hemophilia. So E, a healthy married couple was shocked to learn that their son had hemophilia. As the family doctor, you need to explain to both parents to how do their son inherit the disease. You have to draw the schematic diagram for it, the inheritance of this disease. Right, since they say they are both healthy, right, you know that one of them is a carrier, like this. Okay, and since this question say the son has hemophilia, so you know he's this lah. Exactly like our notes just now. So the dad, okay, the dad is normal because the dad cannot be a carrier, and then the mom is a carrier, right? So when you please remember to split these two first. Okay, many of my students, right, they do like to draw this step, they straight away cross. I mean, nothing wrong with that lah, but there should be one more step here. So first child, okay, normal daughter. Second child, carrier daughter. Third possibility, healthy son. Okay, fourth possibility. So this is the son. Okay, he has hemophilia. Okay, he's a hemophilia son. So how do you, okay, here's the thing. Drawing diagram, you have no problem. But when it comes to explaining, you're kind of stuck. Okay, so how do I explain this? Very easy. You just have to say what genes combine with what gene. All right, so you can say the X small h gene from the mom, okay, fertilizes the Y gene from the dad. So they have a son which has a recessive H, which means he has hemophilia. All right, okay, let me write this. Okay, let me write this. So you can say Y chromosome from the father, okay, fertilizes, or you can say fuses fuses with XH chromosome from the mother. Okay, so you can say the son has chromosomes XHY. Okay, so the son has hemophilia. Right, straight to the point. You just need to explain this. The rest, not your job, because they only want to explain why is my son hemophilia. So that's the reason. Okay, so this diagram will carry you 2 marks. Your explanation would have 2 marks. Easy, right? Easy, right? I don't see how is this chapter hard. For some people maybe lah, but you know my method, you use my method. This is like, I don't know, easy peasy. I hope. Okay, I hope. Right, so I hope that you understand, I hope you understand, because this is we've been doing this thrice already. Once just now, or last week, and once the upper question just now, and then once more here. So yeah, okay, good, that's good. Right, so question 13 and 14, let's not do this first. Let's jump back up here. Let's jump back up to section A here. Right, as I said, this discontinuous and continuous variation, they are usually coming out in your section A. That means they want you to count things. Okay, they want you to count things. Okay, so now by now, you should be able to answer this kind of question already. So let's look at the question here. Okay, let's look at the question here. So number one, we're in page two, we're in page two. So question one, a group of students carry out an experiment to study the variation of pea plants. Okay, so there are a few pea plants here. But does this look like rows though? Okay, anyway, so the results are observed below. So you only see two types. Oh, this one discussed already, huh? Oh, discussed already. Also, this one I think you know how to draw, huh? So now, do you know why this is discontinuous already? This is why this is discontinuous. Discontinuous variation. Okay, because obviously you have a tall class here and you have a dwarf class here. So yeah, that's why this is discontinuous. And then are the hydrangea flowers. Okay, so have I discussed this too? Have I discussed this? Just to let you know, your hydrangea flower, right? When your soil is alkaline, okay, that means if your soil is bitter, then the flower will turn pink. If your soil is acidic, then the flower will turn yellow. Sorry, blue. That means this is a continuous variation. Why? Because this is affected by environment. This is affected by environment. Okay, so why do they have a different color? Because the flower color can be affected by environment. Okay, can be affected by environmental factor. So this is my answer. Can be affected by environmental factor. Okay, so anyway, moving on. Let's go to question 2. So question 2, I think we did this also, right? Oh, we are done for this set. Okay, so obviously you see this graph, okay, when we draw this thing, you can see obviously this is a continuous lah. I'm just sketching it here. So the type of variation, this is a continuous variation. Okay. I was thinking, why are we so fast? Right? Oh, okay, because I don't need to write BM in this class. So wow, God bless. Because usually other classes I have to explain it in BM, so that will take up quite a lot of time. So let's look at number 3. Have we done number 3 too? Oh, 3 haven't. 3 haven't. Okay. So obviously this is the blood group, and obviously this is the discontinuous. So let's look at A. A has how many here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then for B, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. AB, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So O, you have 1, 2, 3, 4, 5, 6, 7, 8. Oh, there's one more AB here. So 17. Okay, so it makes up 50. So we got the total number lah. All right, so what's your blood group though? What's your blood group? Do you know your blood group? Because I don't know. I might be an O. Most of us are O lah. Okay, O has the most people. Oh, yeah, O too. Okay, that's good. All right, so draw a bar chart here. So you know how to draw lah. A, B, O, A, B. I should look something like this. I'm just sketching it for you, okay? You draw yourself, please. Okay, so based on the bar chart, state the type of variation. So what variation is this? Obviously, this is your discontinuous variation. All right, because there's no There's no continuous line here. Very obviously, you can tell them apart. Okay, they are not distinct. Okay, they are qualitative. So you can kind of tell them apart. So yeah, there you go. Right, easy peasy, easy peasy. That's why I say this variation part is most likely a free mark for you. I mean, not really free lah, but it's close to free because it's really that easy. Okay, unless you don't know how to count, then I worry for you. Okay, unless you're like blind lah. Okay, yeah, I wouldn't worry. Okay, I wouldn't worry. Anyway, so we have done all this. Okay, let's go to question 13 and 14. This is not really coming out, but I'll touch on a little bit lah. Okay, I'll touch on a little bit because we have to wait for other classes. You see, this is the good thing. We were supposed to finish this in 2 weeks. You see, if 2 weeks I have to rush like hell and you couldn't absorb. So you see, we started this in the beginning of October. So this is our 3rd week doing this. Next week we have another week of doing this. So next week I might discuss there's another copy of objective, right? We might discuss the objective. So you see, we can do things slow. Okay, I can let you slowly absorb this. So which is a good thing. Because other classes, right, other tutors, right, they actually spend 2-3 weeks on that chapter 9. Imagine, okay, I teach you satellite for 3 weeks. Oh God, luckily I do not. Right, anyway, so what is this? Okay, this is genetic engineering. Okay, let's take a moment to appreciate this. How smart we humans are. Right. If you have diabetes last time, it's like a death sentence. If you are born, okay, first of all, diabetes, there are 2 types. You have type 1 and type 2. Type 1 means you cannot produce insulin. Type 2 means you can produce insulin, but it's just that your body is not responding to it. Type 2 is usually caused by yourself, by eating, sweet stuff every day. So we get diabetes. But the first type 1, you are just born without insulin. And last time, if you have this disease, it's life-threatening. You are going to die soon. All right. But in these days, okay, in this modern era, no. Okay, you'll get it in the future. Why leh? You like sweet stuff, man? Natalie, you have a sweet tooth, huh? I know your problem. I have a very serious sweet tooth too. Okay, as long as you exercise and you don't get obese, you should be okay. So make sure you exercise. I know you hate it, but you have to, right? Because eating sweet stuff carries a responsibility. Exchange fund, okay? Anyway, so what happens here? Right, last time, as I said, we have to get insulin from cows and pigs. They are not very good. Okay, I mean, it helps, but it's not very good because you have to get it from animals. It's not very clean. So what we humans figure out was, you see, this is very smart. We go to our human cell. This is our pancreas cell. If you remember in chapter 7, our pancreas will produce insulin. So we go to a normal human, we take one of the pancreas cell, because a normal pancreas cell, if you're a normal human, you have a normal pancreas cell, you should be able to produce insulin, right? Okay, so when you produce that insulin, so what do? I take let's say you are healthy, I take your human cell, I take your pancreas cell, I take out one of the insulin gene, because to make insulin, you need an insulin gene. So I just take out an insulin gene from you, and I insert this gene into a bacteria. Why a bacteria? Because bacteria, they can reproduce very quickly. So I insert it into a bacteria. The bacteria will photostat themselves very quickly, and they will follow this gene I inserted to them and produce the exact same copy of insulin. All right. So put it this way, it's like I'm taking a page from a book. Okay, I insert it to a photostat machine. The photostat machine is able to create thousands of copies in a few minutes. Very smart, isn't it? So we just use, you see, the insulin I produce, looks exactly the same as a normal human insulin because the instruction comes from this insulin gene. I'm taking this instruction, telling the bacteria what to do. The bacteria will follow my instruction and create the insulin I want. Okay? By doing this, I can make insulin in a very short time and in a large amount. This is how we bring down insulin price. That's why insulin is really cheap because it's very easily produced. I just use bacteria. I can make, many bottles of insulin in just one day. All right. So thanks to this technology, we can afford insulin every day, everywhere. Unless you're in the US lah. Okay, unless you're in the US, they actually fix the price of insulin. They charge you an arm and a leg for insulin, which is freaking ridiculous, okay? Because insulin is very cheap. Right? Anyway, so what is the meaning of genetic engineering technology? Okay, it's the modification of genes, okay, of organisms. Okay, so to modify their gene, you can say to satisfy human requirements, to satisfy human needs, because at the end of the day, genetic engineering is to make our life better. All right, so what is R? Okay, this one you don't need to know. R is a bacteria, by the way. Okay, R is a bacteria. So what is the function of a fermentation tank? The fermentation tank is to let the bacteria reproduce, okay, for the reproduction of bacteria. Okay, so they'll put it in the tank, and this tank is very comfy. This tank is very comfy. It has water, and it is 37 degrees, just nice for bacteria to grow. So it's like a mini cool sauna here. So for them to grow. So what is process K? What is process K? Process K is extraction. We extract out the insulin. Okay, extraction. And then what type of human cell is taken? So like I said, we take it from your pancreas cell. This is chapter 7. We use your pancreas will produce insulin, right? So we take it from a pancreas cell. So in your opinion, what is the advantage of insulin production? Okay, good question. They are identical. Okay, they can be mass produced in a short time. So many you can write. Okay, so they are cheap. Insulin is very cheap. Insulin is very cheap. But in the US, they fix it at $250 per, I think, per pen. They have something called insulin pen. Okay, if you have diabetes, right? If you have diabetes, right? Oh, hey Dyson. Okay, so if you have diabetes, right, you have something called insulin pen. It looks something like this. You will inject yourself with this pen every day. This is the insulin pen. Why? You have one? Do you have one? Girl's best friend. I know, right? Okay, it's like my wife's and my sister's bucket list. Okay, anyway, so this is your insulin pen. Okay, I need to in the future. Okay, so anyway, so this is your insulin pen. Really cheap. If you go to like government hospital, they will prescribe this. I think RM1. Okay, they will give you a month of supply. But if you go to the US, right, you see how you see how ridiculous it is. Okay, in insulin, sorry, in the US. Okay, in the US, I think they fixed it at are there? It's as high as $1,000. Okay, that's one pen. Okay, one pen will last you a week. Okay, so they will fix the pen at around I think 250 if I'm not mistaken. So in the US, you see, US is a very funny country. They have money for military, they have money for guns, but they have no money for insulin. Okay, because the government, the part that's controlling the insulin, it actually belonged to a big pharma company. So they actually fix the price so that they can rip off their people. Awesome, isn't it? So they like to say USA is the best country in the world. Okay, many people's dream is to go to the US. Okay, I was like, why? Okay, it's freaking violent over there. There's tons of shootings. Okay, it's racist as hell. Plus, the healthcare is expensive as shit. Okay, I think I told this right. I think I told this right. One ambulance ride to the hospital is 1,000 US dollar at least. Okay, at least. So in the US, right, if you need to go to the hospital, please call yourself an Uber. It'll be much cheaper. Okay, because even if the ambulance do come, even if they saved you, you cannot survive the hospital bill. Ironic, isn't it? So don't, please don't get sick in the US, okay? So ridiculous. Okay, anyway, so this is what we call amniocentesis. Oh, this is how they scan whether you have Down syndrome. Okay, let's say you're pregnant, right? Doctors will ask you to go for this. They will draw the amniotic fluid, and then they will test whether your baby has Down syndrome. All right. So two importance of this method. This is to detect genetic disease early. All right. Two importance detect genetic disease. I think there's only one though. I don't think there's two to write here. Okay, so name the sample taken. So what are we trying to draw here? That's your amniotic fluid. Okay, so the method used to separate the sample and the fetal cell. You know what? I'm just gonna skip this because I've never seen this question in exam before. So anyway, I think I'm gonna stop here lah. So I think we wrap chapter 5 up. I hope this is helpful for you. Next week, right? Okay, do you know you have that objective question together with this? Please go home and do that. Okay, next week I can give you the answer. If you want me to discuss, I'm okay too. So if we manage to finish early, right, I might go into chapter 6. Okay, I know you don't have the notes yet, but I'll give you chapter 6. You need to take recordings. Oh, okay. Oh, okay, sure. Oh, then best of luck to you. Best of luck to you. Okay, I hope this is helpful. I hope this is helpful. Right, so if you have anything, don't hesitate to WhatsApp me. If you need to revise anything. If you need the answer for that chapter 5, you tell me. Okay, I can WhatsApp you. No problem. Not helpful to UEC, but helpful. Oh, okay. Also, that's a UEC exam. All right, best of luck to you. Okay, so anyway, if you have no question, I will see you next week, or I'll send you the recordings next week. Okay, so best of luck to you. I will see you again. All right, so take care. See you. Happy Wednesday and bye bye.